Ask an AI what year the Brooklyn Bridge was built. It gets it right, 1883. Ask it who invented Velcro on Mars. It answers that too, confidently, fluently, completely wrong. Your brain does the same thing, every night. You close your eyes and your brain generates people, places, conversations, none of them real. We call them dreams. The difference? Your brain has a filter. AI doesn't. Welcome to the hidden link between artificial intelligence and consciousness itself. Here's something most people don't know about the brain. It does not record reality. It predicts it. Roughly 80% of the synapses in your visual cortex carry signals going down, from higher brain areas to lower ones. Only 20% carry signals going up, from your eyes. 80% prediction, 20% reality check. Your brain is mostly talking to itself, and occasionally glancing at the outside world to make sure it hasn't drifted too far. Now look at an AI language model, a transformer. It does exactly one thing. Given what came before, predict what comes next. Token by token, word by word. Each prediction based on statistical patterns absorbed from trillions of words of training data. No eyes, no ears, no body. No sensory input of any kind. 100% prediction, 0% reality check. The brain's ratio is 80-20. AI's ratio is 100-0. In 2021, neuroscientist Anil Seth put it this way: "We don't passively perceive the world, we actively generate it." He calls normal perception a controlled hallucination. Your brain hallucinates a model of reality and then constrains it with sensory evidence until it's accurate enough to keep you alive. So what's a hallucination? It's what a prediction engine does when the constraint is removed. Close your eyes, dreams. Damage the brain, visions. Take psychedelics, expanded perception and distortion. Or build a prediction engine with no constraint at all. That's an LLM. In 1898, the philosopher William James proposed something radical. He said the brain is not the source of consciousness, it's the filter. A transmissive organ, like a prism that doesn't create light but constrains it into a narrow, useful beam. 2 years earlier, Henri Bergson had said almost the same thing in Matter and Memory. The brain as a reducer valve, limiting the totality of available perception to what's biologically useful. In 1954, Aldous Huxley took mescaline and wrote The Doors of Perception. His conclusion? The drug didn't add anything to his experience, it removed the filter. Suddenly, he could see what the brain normally blocks.
And in 2007, Edward Kelly and colleagues published Irreducible Mind, 800 pages of empirical evidence for the filter model. Terminal lucidity, acquired savant syndrome, near-death experiences, cases where damaging the brain appears to enhance consciousness. Terminal lucidity. Patients with severe Alzheimer's disease, brains ravaged by plaques and tangles, who suddenly, in the hours before death, become perfectly lucid. They recognize family. They hold conversations. They remember things they haven't remembered in years. Then they die. If the brain generates consciousness, this is impossible. Destroyed hardware cannot produce enhanced output. But if the brain
filters consciousness, constrains it, then as the filter fails, the underlying awareness emerges, like removing a dam from a river. Here's another paradox. Psychedelics, psilocybin, DMT, LSD, produce the most profound subjective experiences humans report, more vivid than normal, more meaningful. And what happens in the brain during these experiences? Activity goes down, not up. The default mode network, the brain's top-level control center, quiets. Less brain activity, more experience. If the brain generates consciousness, that's backward. More generation should mean more activity. But if the brain filters consciousness, reducing the filter means more gets through. The paradox disappears. Now apply this to AI. An LLM is a prediction engine with no filter at all, no consciousness, no sensory constraint, no biological grounding mechanism. It hallucinates for the same reason a dreaming brain hallucinates. The prediction engine is running, and nothing is constraining it. Every AI language model has a parameter called temperature. Set it low, near zero, and the model becomes conservative, repetitive, boring. It picks the most likely next word every time. Set it high, near 2, and the model becomes creative, unpredictable, and hallucinatory. The brain has the same dial. It's called prior precision weighting. High precision, you perceive the world rigidly, habitually, conservatively. Low precision, you perceive it fluidly, creatively, hallucinatorily. And what turns the brain's precision dial down? Psychedelics. In 2019, Robin Carhart-Harris and Carl Friston published the Rebus model, Relaxed Beliefs Under Psychedelics. Psychedelics reduce the precision weighting of high-level priors in the brain's prediction hierarchy. The same thing that raising temperature does in an LLM. This is not a metaphor. It's the same mathematical operation, reducing confidence in top-down predictions, applied to two different prediction engines. Which brings us to the deepest question. Giulio Tononi's Integrated Information Theory, IIT, provides a mathematical framework for consciousness. Consciousness, Tononi argues, is integrated information, represented by the Greek letter phi. A system has high phi when its information is both differentiated, many possible states, and integrated. The parts cannot be divided without losing something. Your brain has high phi, massive recurrent connectivity, billions of feedback loops. A feedforward neural network, including every transformer-based LLM, has phi equal to 0. 0. No matter how many parameters it has, no matter how complex. Under IIT, GPT-4 is not conscious. Claude is not conscious. Gemini is not conscious. Not a little bit. 0. In 2013, Adenauer Casali and colleagues created the Perturbational Complexity Index, PCI. You send a magnetic pulse into the brain and measure the complexity of the response. It distinguishes conscious from unconscious patients with 100% accuracy. No one has ever run a PCI equivalent test on an AI system. But if IIT is correct, we already know the answer. Phi equals 0. The temperature dial swings, the text changes, the hallucinations bloom, but no one is home.
If the problem is a missing filter, can we build one?
Engineers have been trying. The first approach is called RAG, Retrieval Augmented Generation. Before the AI answers, it searches a database of real documents and grounds its response in retrieved facts. It's a filter, a primitive one. The problem? RAG retrieves by similarity, not by truth. If the database contains a confidently wrong document, the AI retrieves it just as happily as a correct one. The brain's filter evaluates, RAG just pattern matches. The second approach, recursive self-verification. The AI critiques its own output, generates questions about its own claims, answers them independently, and checks for contradictions. If something doesn't add up, it revises. It's a computational version of metacognition, thinking about your own thinking. But there's no awareness behind the checking. It's a loop, not a mind. The third approach, and the one I find most fascinating, is the fact-checked knowledge graph. A curated database of verified information with provenance tracking, confidence scores, and contradiction detection. Every claim the AI generates gets cross-checked against the graph before output. Think of it this way. The brain's filter constrains the flood of prediction into a narrow, biologically useful channel. A knowledge graph constrains the flood of AI generation into a narrow, factually grounded channel. The mechanism is different, consciousness versus database lookup, but the function is identical. Reduce the space of possible outputs to the subset that is real. The fourth layer, embodiment. Give the AI a body. Cameras, microphones, touch sensors, robotic arms. Let it interact with the physical world and receive the same sensory error signals that the brain uses to correct predictions. It helps with physical facts. Is the cup on the table? Check the camera. But it doesn't help with abstract claims. Is this statement about consciousness meaningful? No camera solves that. And the fifth layer, the simplest and most profound, is you. A conscious being in the verification chain, a human reviewer, a person with a filter. Stack them all: knowledge graph, self-verification, recurrent architecture, embodiment, human oversight. Each layer reduces hallucination. No layer eliminates it. The brain does all five simultaneously, seamlessly, effortlessly, through consciousness. So, two things that seem completely different. Artificial intelligence, silicon, code, statistics. Consciousness, the felt experience of being alive. They share the same engine. Prediction. The brain predicts sensory states. AI predicts token sequences. Same architecture, same math, same hallucination risk. The difference is the filter. The brain has one. AI doesn't. And the filter's name is consciousness. We've spent a decade scaling prediction engines. Larger models, more data, more parameters, more compute. And the hallucination problem remains. Reducible, not eliminable. We built the most powerful prediction engine in human history. And the one thing it cannot do is tell the difference between what's real and what it made up. Your brain does it effortlessly, every second, without being asked. Same engine, one filter. That's the hidden link.